So here they are asking us to draw the Rayleigh curve. So the curve is drawn between enthalpy and entropy. And assume this is the reference line. Okay, this is the reference line I am taking. So this is the subsonic curve. This is the supersonic curve. This is the m is equal to 1 point. So now in the station 1 they mentioned this is supersonic. Okay, so due to the heat addition, maybe the supersonic value might have reduced. Then there is a normal shock. Then behind that it should be subsonic. If you further add the heat, then this flow will increase. So here it will decelerate, here it will accelerate. This is the condition they are given. Even if you want to clearly understand, you have given some Mach number. For example, okay, I can take Mach number 3 here. If you keep on add the heat, assume it is reduced to 2, Mach number 2 in the station 2. Then there is a normal shock. Assume this normal shock convert this Mach number 2 to some 0.7. Okay, Mach number 0.7 subsonic. Then further heat addition may accelerate this to the high subsonic or even maximum 1. Okay, they haven't mentioned whether it is high subsonic or 1. Okay, so anything you can take it. So assume I'm keeping Mach number 3 point here. In the exam also simply they will give this type of duct. So for that you should draw the Rayleigh curve or Fano curve. So I suggest you can give some Mach number value so that you can easily understand and draw the Rayleigh curve or Fano curve. So initially my Mach number is 3. Then due to the heat addition, it is reduced to 2. Then there is a normal shock. So this point should be mentioned here. Okay, sorry. Which is Mach number 0.7. Then further heat addition may accelerate to subsonic, or even you can mention that as the sonic. So Mach number 3, then 2, then there is a normal shock with the increase in entropy 0.7, maybe 0.9 here. Okay, if you want you can expand this to 1 also. So there is no thing given here. Then next to problem, so this also easy only. So again they mention constant area combustor. So in the inlet they are given T1, P1, then velocity, then what is the Q value, then Cp, that means this is not the air. Okay, this is some other gas. So for that we should find M2, P2, T2, also the Q max value. So P1, T1, V1 is known, Cp also known, Q also known. So how will you proceed? Almost for all the problems in the compressible aerodynamics, your first step should be searching for the Mach number or try to find the Mach number. Okay, once you know the Mach number, then you can easily refer the gas table. If the Mach number is not available, then you should go for some ratios, pressure ratio, temperature ratio, those things and all you should try. Is that clear?
Yes, sir.
So here the velocity is given, so you should try to find the Mach number first. So using that you can find M1. This is the first step. Then second step, next step.
So for the M1, we find the ratio between T1 and T01
Okay, so we
using
will go to
isentropic
isentropic
table.
table. Okay, we will find T1 by T01, P1 by P01. Then maybe
So
you
then,
know T1, P1, you can find T01 and P01.
so then Q is given, Cp is given, and T01 is given. So we can find T02.
Okay, very good. So using the Q formula, Cp, T01, everything is given. So you can find T02. Then so we found T01, P01, T02. Now So by seeing that problem, you should identify whether it is isentropic, normal shock, oblique shock, Rayleigh, Fano. Okay. So here combustor with the heat transfer. So this is Rayleigh table, Rayleigh problem. So you should go to the Rayleigh table. Hmm? We should find whether we can get any ratios from that Rayleigh table. Is that clear?
Yes, sir.
So next step, we should search for the Rayleigh table. So we know M1. So I think you can find P1 by P star, T1 by T star, T naught 1 by T naught star, P naught 1 by P naught star. Externally you can find it. So you know P1, T1, P naught 1, T naught 1, all the ratios you can find it. Next step.
So we found T naught 2, so we can use T naught 2 by T naught star
Okay, very good. This is
and
almost
find
like
M2.
the general procedure we explained it, how to solve it. Same procedure, only one step additional, that is finding this M1. Other than that, it is same. First isentropic, then Q formula, then Rayleigh table, then T naught 2 by T naught star. Then again another one time you have to refer the Rayleigh table. You can find M2. Okay, correct your procedure. So P2 by P star, T2 by T star, T naught 2 by T naught star. Sorry, P naught 2 by P naught star. So we know all the star properties. We can find P2, T2, P02, M2, etc. and all. Additionally, they asked Q max. What is this Q max formula? That is Q max means. So what is the Mach number you should assume in the exit?
1.
1. Okay, Q is given. Now they are asking us to find Q max also. So normal formula will be T naught 2 minus T naught 1. For this Q max, will we take T naught 2 or some other value?
We'll take T naught star minus T naught
We will
1.
take T naught star. Okay, so if you use T naught 2, you will get this Q value. If you use T naught star, you will get Q max value. So T naught star already we found it. Substitute T naught 1 also known CP is given. You can find Q max value. That's it. Is it clear this problem?
Yes, sir.
Okay. So first we are finding Mach number, then isentropic table. Okay. Then second step, using the Q formula, we are finding T naught 2. Then third step, using Mach number, all other ratios. From that we are finding all the sonic properties. Sorry, all the sonic properties. Then fourth step, using this T naught 2 by T naught star, again Mach number and other ratios. So once you know the sonic, you can find all the statics. Finally, Q max, where m is equal to 1. Okay, so T naught star minus T naught 1. So we are getting the Q value. This is one last problem. So then you can go for the Fano flow. So here we have a long duct and we have 4 stations. So they have mentioned M1 is 1.6, then T1 is 200 Kelvin, then okay, M4 is 1 and P4 is 1.2 bar. So P1 also given. P1 is 0.56 bar. So these information they are given, and we have to find this Q value, also the direction. So how will you proceed here? So here supersonic, then we don't know whether it is heat addition or rejection, whether this flow got accelerated or decelerated, but here also it is supersonic because there is a normal shock, correct? then the normal shock convert that into the subsonic. Then here there is no shock, there is no heat transfer. Simply there is a convergent duct like a normal isentropic flow nozzle. Okay, so here it is non-isentropic. Across the shock also non-isentropic, but here it is isentropic. So this subsonic flow is accelerated to sonic. Is that clear? The problem given?
Yes, sir.
So now tell me how to proceed. So once we find M1, we can find both isentropic and Rayleigh formulas. Even if you have Mach number on both sides also you can try. Okay, we will try that first. Very good. So I know M1. I'm going to the isentropic table so that I can find P1 by P01, T1 by T01. Even here there is a heat transfer. So this is a Rayleigh flow. I can go to Rayleigh flow table also. Okay, so I can find P1 by P star, T1 by T star, T01 by T0 star, P01 by P0 star. Second step. And even I know Mach number and the exit. So my third step, maybe I can take M4. I can go to the isentropic table. I can find P4 by P04, T4 by T04, like that. I can find all the ratios first. That's correct, right?
Yes,
So in
sir.
the station 4, I cannot take Rayleigh table because there is no heat transfer in this duct. Now, by seeing this ratio, you tell me how to proceed further. Even what you can do from this ratio, you can find T01, P01, right? Similarly, from here you can find P04. Am I correct?
Yes, sir.
So up to this you can do it. Okay, you can simply take all the ratios. So wherever possible, you should take it from isentropic and Rayleigh table, and you can find at least that stagnation static property in the particular station. Now tell me how to proceed. I need this Q value. So what is the formula? Q is equal to Cp T02 minus T01. So Cp is air value and T01 just now I found it. So what I should find is T02. Okay. So if I know T02 value, I can substitute here and find the Q value. Okay. So this one I have to find it. Now tell me how can I proceed to find the T02? So that is T02 means in the station 2 I should find the properties. So in this station 2 I should find the property. But again, so whenever if you want to find some property in the station, so if you know the Mach number, it would be very easy to find remaining property, right?
Yes, sir.
So if I know Mach number here, I can easily find other property in this station too. So to find this T02, first I should find the M2. This is isentropic, right? So P0 is constant, T0 is constant. Even I can write this P04 is equal to P03. So maybe we will try the Rayleigh graph. We will see. You will get any idea or not. Okay. So initially I have Mach number 1.6. I don't know whether it is cooling or heating, but it is converted to some supersonic value. So okay, I will take it. This is my 1.6 point. Okay. So if there is a heat addition, then it might have moved in this direction, right? 1.6 might have reduced
Yes,
to
sir.
1.43 something. Then okay, this should be my second point. Then there is a normal shock. Sorry, assume I will take just 1.4. Okay, so then normal shock will convert that Mach number 1.4 to some, assume some 0.7 I am taking. 3 to 4, there is no Rayleigh. Okay, simply it is isentropic flow convergent type. So for the isentropic flow, entropy is constant. So it will be like this. Okay, somewhere here, the fourth point. So from 1.62, due to the cooling, it may be further increased. Maybe 2. Then from there is a normal shock 3. Then from there, I will get the isentropic line. Is that clear?
Yes, sir.
2 dash, 3 dash, 4 dash. So these are all the both possibilities. Okay, heating means this direction, cooling means this direction. So we don't know which line it will follow, but now we see what we found. We found P03. Okay, so we found P03, and this P03, this station 3, it is on the Rayleigh curve. So if I know P03 by P0 star, I can find M3. Is that clear?
Yes, sir.
See, P03 is known, P01 is known. If you substitute here, you can get P0 star. Okay, once you know the P03 and P0 star, then you can go to the Rayleigh flow table. You can find the M3 and other properties. T3 by T star, P3 by P star, T03 by T0 star. Everything you can find it. So once I know this ratio and find M3, from that how to find M2?
So if you find M3, we can go to the normal shock table and find.
Very good. You can go to the normal shock table. If you know M3, you can find corresponding M2. What I need is this T02. Okay, and M2 also it is in the Rayleigh curve only. So once I know the M2, I can go to the Rayleigh flow table. I can find T02 by T0 star. Okay, so T0 star already I found it. Okay, maybe here. If you know T01, I can find T0 star. Substitute here, you will get T02. That T0 you substitute here, you will get the Q value. So minus means there is a cooling process. Okay, so cooling, what will do? If we take 1.6, heat addition will decelerate the supersonic. So heat rejection, it will accelerate the supersonic. Now we will see M2 value. So from 1.6 it increased. Okay, so 1.6, due to the heat rejection, it is accelerated to 2.9. Then there is a normal shock which convert 2.9 to 0.481. Then there is a divergent. So this 0.48 again accelerated to 1. Like that, this problem went. Is it clear?